Hey everyone, welcome back to another SAT math video. This is question 27 from the official 2024 Test Bundle 5 Math Module 2, linked in the description below so you can follow along. For an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength. So there's a keyword, product of the electric field strength, and the area of the surface, right? A certain flat surface consists of two adjacent squares where the side length in meters of the larger square is 3 times the side length in meters of the smaller square. An electric field with strength 29 volts per meter 29 volts per meter passes uniformly through the surface, which is perpendicular to the electric field. If the total electric flux of the electric field through the surface, and this is the total, right? Total electric flux through the surface is 4640 volts times meters. What is the electric flux in voltmeters of the electric field through the larger square? So this is a pretty complex problem. I wouldn't really say it's a hard problem, but it does require a lot of steps and careful math, right? So let's be very careful and slowly solve this problem. So what they are telling us, right? First, let's understand how to calculate flux, right? They're telling us flux is some surface area, and then the surface area is going to be times the electric field, right? Where the electric field is perpendicular to the surface area. That part doesn't really matter because we are told that in our question, the electric field passes uniformly through the surface perpendicular. So we don't really care about that part. But now what else do we know? We also know that we have two squares, right? We have one square and then another like smaller square, and the smaller square has side S and the bigger square has side 3S, right? And this has some area A1 and this has some area A2. Okay, and what else do we know? We know that E, the electric field, that is equal to 29 volts per meter, and we basically know that the total flux, right, let's just call that maybe ft, that is equal to 4640 voltmeters. Okay, so what can we do? We need to basically figure out the flux. We need to find the flux of, let's say, just the electric field passing through this larger square, right? Let's call that L for larger square, right? We need to find that. Okay, so to do that, we first need to figure out the area of the larger circle, right? Or not circle, the larger square, right? And how can we find the area of the larger square? Well, we are given the total flux of the entire surface area, and we could basically use this value and in combination with the electric field value to find out the surface area. And then once we find out the total surface area, we can figure out the side length. Once we know the side length, we know the area of the bigger square, and then we can just redo the same equation to find the flux of just the larger square. So it'll make more sense once I get into it, right? So let's first rewrite this equation, right? Flux is basically going to be A1 plus A2, because that's going to be our total surface area, times E, right? A1 is nothing more than 3s squared, right? Because we have to do 3s times 3s, and A2 is going to be s squared, right? So here we're going to have F is equal to 3s, and that's going to be all squared plus s squared times E, okay? Let me move everything down a little bit. So now let's continue. Let's simplify this a little bit. So then F is going to be equal 3s squared is going to be 9s squared plus s squared. We're going to have a 10s squared times E, right? And we want to basically solve for s, right? So what I'm going to do is just keep it all in terms of variables, and then isolate S, right? So what I'm going to do is divide by E, both sides by E, and then we are left with F over E is equal to 10S squared, divide by 10 as well. So then we're going to be, I'm just going to move that up here. So then we are going to be left with F, and whatever you do on one side, you do on the other side. So you can divide this side by 10. So that becomes F over 10E is equal to S squared. So therefore S is equal to the square root of F over 10E. Okay? So why did I do it this way and not plug in the values immediately and solve? Well, this way you kind of already know how to plug in your numbers into your calculator, and it just makes things a little bit more organized and easy to solve later on. So I personally prefer this method just because you only have to plug in stuff into the calculator once and do like kind of one calculator operation. Whereas if you were doing in the beginning, you have to do multiple calculator operations, and it can kind of lead to some unintentional errors, right? So let's plug in our values. F is 4640 voltmeters, right? So this is going to be S is equal to the square root of 4640 voltmeters over 10 times the electric field. And our electric field is how much? It is 29 volts per meter times 29 volts per meter. Okay, so let's try and simplify this now a little bit more. So first, let's make sure we have the right units at the end. So voltmeters divided by volts per meter, right? That's the same as voltmeters times meters divided by volt, which would be the same as, let me just move this over. This is going to be the same as, well, the volts and the volt will cancel out, so we'll just be left with meters squared, and then this is under the square root, so we are left with meters. So that makes sense, right? So at least now we know that our math is going to make sense because our unit is going to be in meters, and we expect it to be in meters because it is the length of a square, right? So now let me move my screen back over. So what we have here is 4640 divided by 10 times 29. So we know this answer is going to be in meters. So I'm just going to write meters at the end here. And then 4640 divided by 10 times 29, that's the same as 4640 divided by 290 all square rooted, and it's some value in meters, right? We can cross out the zeros. So then S is going to be equal to 4640, or not 40, 464 divided by 29. So, and then that's going to be square rooted, right? So what I'm going to do is I'm going to use my favorite long division to figure this out. You can use your calculator. I fully expect you to use your calculator, but in case you don't have your calculator, maybe it's ran out of batteries, this is how you'd be able to do it without it. So 29 goes into 46 one time. We write the 29 over here, borrow 1 after we have to subtract, so that becomes a 3. 16 minus 9, that is 7. This is going to be 174. Now you might think, oh my god, I don't know my 29 times tables. How am I going to figure out how many times 29 goes into 174? Well, I like to just look at the units place number and see, okay, what multiple of 9 ends with a 4? And I know 9 times 6, or 9 times 6 is 54, right? So let's try that out. 6 times 9 is 54, carry the 5, and then 6 times 2 is 12, plus 5, 17. Oh, look at that, pretty easy, right? So just a little trick in case you are stuck doing long division because you maybe forgot your calculator, something like that. So we know 29 by 4, or 4064 by 29 is going to be 16. So we have the square root of 16 meters, or in other words, S is equal to 4 meters, right? So that's actually not our answer, right? Because we want to know, what do we want to know again? We want to basically know what is the flux of the electric field going through the larger square, right? Recall that flux is equal to surface area times the electric field. We know the electric field. Now we can also figure out the surface area, right? So we just need to plug it into our equation and figure it out, right? So we know that the area of this circle, right? The area of the larger square, I'm sorry, not circle, is going to be 3s squared, which would basically be 3 times 4 squared. So in other words, the area of the larger circle or the larger square is 144 meters, right? Because we have our answer in meters, because 3 times 4 is 12. 12 squared is 144. And we know that our flux is going to be the area times the electric field perpendicular to it. So F is going to be 144 meters times 29 volts per meter, right? Or not 29 volts. Yes, actually, 29 volts. Oh, and this is actually going to be meters squared, right? Because we have basically S is in meters. So you can imagine this 3 times 4 meters, right? The meters get squared too. So yeah, that's just one thing to keep in mind. So 29 volts per meter. And let's just figure out our unit first, right? Meters cancels out with one of the meters in the meter squared. So we are going to be left with some value times or some value in voltmeters. So that's another indication that our logic is sound because we ended up with the right unit. So now we just need to do 144 times 29. You could also do this in your calculator. I like to do stuff by hand because I don't have a calculator with me right now. So let's try and do this. 4 times 9 is 36. 4 times 9 is 36 plus 3, that's going to be 9. Carry the 3. And then 9 times 1 is 9 plus 3 is 12. Let's move down a little bit. Oops, that's not what I wanted to do. I wanted to do this, right? Now let's continue. Now we did the 9. We're going to write a 0 here. 2 times 4 is 8. 2 times 4 is 8. 2 times 1 is 2. Add it all up, 6. We get 9 plus 8 is 17. 2 plus 8 is 10, plus 1 is 11. 1 plus 2 is 3, plus 1 is 4. So our final answer for the flux going through the larger square is going to be 4,176 voltmeters. So there you have it. Not a super difficult problem, but you did have to read very carefully and do a lot of steps, right? So it definitely was a longer problem. Don't feel discouraged if you didn't immediately get it, because it is a pretty complicated problem. You had to first understand what the formula for the flux is, then you had to understand how you could actually get the side length, right? You can get the side length of the larger square by basically using the flux of the total surface area of the big square and the smaller square, and then solving for S. Once you solve for S meters, then you simply had to calculate the area of the larger square times the electric current that was traveling perpendicularly through it. And once you did that, you were able to get the flux of the larger square. So hopefully that made sense. Let me know in the comments below if anything was unclear or if there's any way that I can improve these videos. As always, check out Khan Academy. It is linked in the description below. And also the test that I'm doing right now is also linked in the description below. So feel free to do that and follow along with me so you can, get more practice and hopefully make these videos more useful for yourself. And of course, thank you so much for watching, and I'll see you in the next video.